Everyone, my name is James Dingle. I'm going to be taking you through basically a quick introduction of what the Copernicus Marine Environment Monitoring Service, otherwise known as CMEMS, can offer you. Give you some information about its background, as well as how to access the various datasets within it, and then more specifically, how to find what you want within the datasets within it. As mentioned, I work at PML alongside Haley, except my way in was more of a computer science background, and I've only recently, past couple of years, been working with a lot of scientists to try and bring the technical aspect into the development of various algorithms and products. A lot of my interests revolve a bit about that. Things like grid processing, efficient processing to keep high resolution data to a minimal processing time, as well as maintaining various systems, such as at PML we actually feed in one of the CMEMS products, or two I think, which needs to be delivered within a specific time frame, so keeping the systems going is quite important. As well as trying to provide a technical insight to people with ideas that may not know exactly how to implement them. So first off, what is CMEMS? CMEMS is the last, or one of the last stages of the Copernicus program. So you've got satellite data collection, in situ data collection, and then the services aspect, which brings it all together. This was originally tested in a 6-year phased plan called My Ocean project, which had 3 separate phases, which ended up basically giving you the system we have today. And it targets 4 main areas of eventual benefits, which is to do, as previously mentioned, with safety of people on board vessels, monitoring marine resources, make sure we're not damaging them, or rather monitor how much we're damaging them, checking out the coastal and marine environments for things like surfing and whatnot, as well as keeping track of climate change and how the oceans are changing. So where does it fit in with everything that's been mentioned so far? EUMETSAT and a bunch of other institutions provide a lot of data from the satellites, but this is mostly coming in what we call level 1 or level 2 or level 0 data, which I'll go into in a second. And this is essentially the unedited data at level 0, which gets slowly more and more refined as you go through the levels. So this is shamelessly stolen from the NASA website. But essentially, level 0 is what we receive from the satellite, with some communications artifacts removed. And then at level 1, we have started to add some ancillary data and time referencing to make it actually useful in terms of applying it to science. At level 2, we start applying various scientific algorithms to get access to the products that we've been talking about. Things like chlorophyll is derived from various wavelengths from the spectrophotometers, and pretty much all of it is to do with measuring either color, heights, or temperature. So the bit that CMEMS provides is then coming from level 2. We now apply these products to a uniform grid and kind of try and add a consistency element. So we'll collate all the data from a day or a week or a month and then provide that as a product over and over again. And this allows inter-comparison, so no 2 satellite passes will be exactly the same area usually. So this allows quite a lot of scientific analysis to go ahead. And then we have the last level, which is level 4, which is output from various models, which have been trained on measurements that have been taken, or also combinations of the 2. So level 3 data at the daily and weekly scale still has a fair amount of gaps in coverage. Monthly is a little bit better, but still there are areas which are mostly covered with the cloud. So you can use historical measurements and predict the kind of values that should be there, and provide a mixed product which has a much better idea of what's going on. And this also involves forecasting. So a lot of the weather forecasting will come under level 4. So how does it work? The product is originally and currently still coordinated by Mercator Ocean in France. The data are processed by various institutes around Europe, including PML, where myself and Haley work. You'll find 3 different kind of categories. Timeliness. One is near real time, where the data are produced essentially as fast as you can after reception, and then uploaded to the CMEMS servers. Then we have delayed time, or the reprocessed products, which is the same data but then reprocessed using more up-to-date ancillary data to provide a more accurate product. And then the historical and forecast elements are, well, historical can be reprocessed as we get better calibration numbers for the satellites, and forecasting is just an ongoing process. As mentioned already, the data are freely available to everyone, although you will have to register on the CMEMS site to actually physically download files, but you can play around and view them in the portal on there. And primarily, as is the industry standard now, the data are provided in NetCDF files, which stands for Network Common Data Format. And we can provide help accessing those and reading them if you need to. Okay, so first off, where to access the data. The site itself is pretty straightforward, but I'll go into a little bit how to use it. I'll provide the link to everyone afterwards as well. Essentially, if you're just looking for ideas on something to play with, like you don't know a specific application, the choice can be a little overwhelming. I think there are over 150 products that you can choose from on the CMEMS website. But you can narrow down your choices if you have an area of interest, say, or a specific parameter like sea surface height, waves, or multiple parameters, or even a time of interest if you're investigating specific events that have happened in the past, or you want to provide forecasting data, and that limits your choices. So the first one, and possibly the biggest one, is the area of interest. CMEMS itself provides 7 main areas of interest, one of which is global, which is quite a big area. But these include global ocean, Arctic oceans, the Baltic Sea, this is a bit of a mouthful, the European Northwest Shelf Seas, and the Iberia, Biscay, and Ireland regional seas. And then you've got the Mediterranean Sea and the Black Sea following on from there. These are just some examples to show. Obviously, this is the global product, showing an SST image. This is the Arctic Ocean. There can be some difficulties with this one, with the polar orbiting satellites, because in the winter months, these regions are mostly dark, in the north at least. So, but it can be useful to monitor things like sea ice levels in the winter. And I think we have microwave sensors that can see through clouds. The Baltic Sea is of special interest to a lot of the Nordic countries to monitor how the ships are affecting the water quality, because it's quite an enclosed ocean, sea. And also we get a lot of validation of this data through those ships, because there's this thing called ships of opportunity where they have sensors attached to the bottom of them, which constantly feed back data to us, or to anyone. I've included these two in the same slide because the Iberian, Biscay and Ireland regional seas are included within the Northwest Shelf Sea, but this is really useful for us, especially in the UK, but also to identify processes that interact between the Atlantic and the Mediterranean, for instance, as well as you can line this up with a lot of weather systems which are approaching Europe. And then this leads into the Mediterranean Sea, and finally, Black Sea. So the parameters, you might be confused, is an absolute minefield of acronyms, so I'll try and keep it as simple as I can. They're split into 3 main types, which are physics or physical parameters, biogeochemistry, like stuff that Haley was talking about, and waves. So the physics is a lot of things like temperature, salinity, wave heights, sea ice, velocity, and winds, and you can get some really nice products. I've included an example of the Agulus current underneath South Africa, and although it doesn't really appear, there's actually vectors in this data which you can use to do things like track debris, like Haley was outlining. After that, we've got biogeochemical markers, which is a lot of the ocean color stuff that we do at PML, as well as various nutrients like phosphates, sulfates. Probably won't mean much unless you have a science background. And turbidity is another one that Haley mentioned, where you can see how active sediment is in the ocean. And finally, we've got the waves, which we've sort of covered, which involves wave direction, wave height, and importantly, period as well. So this can be used to analyze how choppy the sea is. So that's me. Unfortunately, I have no animated GIFs to worry you with. But I'll also,
next time.
I will next time, yes. I'll also be here for the entire weekend. Like I said, my background is more of the technical programming side. So if you have any questions or need some help with that, feel free to ask.